All right. Good afternoon, everybody. Thanks for joining us today. This is Sean here at Zyxel. A few of you may know me. I've been here since 2003. It's been a long, long time. So we've done presentations in the past where we talk about our Wi-Fi 6 APs. We've done some Wi-Fi 101 presentations where we talk about a lot of the technology. But something we haven't done in a long time is just talk about our general Wi-Fi product line, sort of just as inclusive hardware overview, and just some of the basics on the hardware itself. So I thought that would be something to try out today. So this is what we're doing today. As we go through, if you have any questions, use the question and answer interface in the Zoom to send in the questions. I may be able to answer questions as we go. If not, we will get to questions at the end. So right now, when it comes to our Wi-Fi access points, we're basically splitting them up into two categories. Those models that start with the number 1 or start with the number 2, we'd call it our flexibility lineup of products. These are our Nebula Flex products. So these APs can be managed either directly by going into the GUI on the access point, or you can choose to manage them in the Nebula Cloud. On the ultimate side of things, those are our models that start with, whoops, I'm getting a phone call. Let's mute that. Sorry about that. Are those models that start with the number 5 or the number 6. So those models tend to be our Nebula Flex models, excuse me, Nebula Flex Pro models. So what that means for you is they can be managed directly through the GUI. They can be managed in the Nebula Cloud. They can also be managed with a controller. These models also include 1 year of Nebula Pro license, comes bundled with each of the APs. So if you are using it in the Nebula Cloud, you do get that extra license. These APs also include some other technology that you won't find in the flexibility line of products. So not all models will have each of these technologies, but this is where our products go that have dual optimized antenna technology, smart antenna technology, our outdoor products, and products that have a third dedicated monitoring radio or built-in Bluetooth. So let's quickly go through here the hardware. So whether we're talking about our cheap little sub $100 access point, or whether we're talking about our flagship AP, we use the same basic design philosophy for all of them. So all of our APs are using solid state capacitors. So access points are what we would call a solid state device. There's no moving products. So what causes failure in these devices over time? So one of the number one causes of failure in solid state devices is the capacitors, specifically electrolytic capacitors. They're basically little tubes filled with salt water. They can leak, they can dry out, they can boil over. So we've eliminated those and are only using solid state capacitors on our devices. The other leading cause of failure on a solid state device is heat fatigue. These products are, your chips are made up of, thousands or millions of little teeny tiny switches moving back and forth. And as boards and stuff heat up, these switches can fail, solder joints can fail, etc. So the way we deal with that is all of our APs will have this big metal shield behind the PCBA. So this acts as a heat sink, drawing heat off of the board and off of the components on the board and venting it out the vent holes in the back. If you look at some of our competition, they don't even have vent holes, let alone any sort of heat sink. And if you grab one of our products and you grab one of our competitors' products, you will notice our product feels heavier in general. And this is one of the reasons why our product is heavier, because we've got this extra metal we've put in there to help prolong the life of the product. And that's why all of our access points, even the cheap sub $100 ones, come with a lifetime warranty. Some of the other stuff we do is we have significantly more EMI shielding on the board itself. So this is designed to prevent interference between the different components on the boards. And it just helps a little bit with the receive sensitivity and making sure there's just that much less noise coming into the signal coming in from the antennas. We also have another large metal plate above the PCBA, above the shielding, which is also there to help draw heat off the board and vent it out and pull it off the PCBA and off the components. It's also designed to help provide extra shielding to keep noise from getting into the access point and onto the components directly rather than going through the antennas. And the other thing you will see is we do not build our antennas into the PCBA, unlike most of our competition. The PCBA is located on its own separate board, or excuse me, the antennas are located above the PCBA on their own separate board above this anti-noise spreader, creating additional isolation between the signal that's picked up by the antennas and what makes it into the chips for processing. Another technology you will see us use on a number of our products here is called dual optimized antennas. Now, your traditional access point basically has one fixed antenna pattern. It's optimized for you to mount that access point on a ceiling, facing down, and covering basically an area around it. So because of that, the coverage pattern is generally radiating out in a circular pattern from where that access point is. The problem you run into is oftentimes, for whatever reason, you can't mount your access point on the ceiling. You end up having to mount it on a wall. So now your access point is mounted basically 90 degrees from where it's expected to be and where it's optimized to perform. So instead of, generally covering the area, a bunch of the signals going up into the ceiling, down into the floor, and you're just not getting good coverage. And if you're on a multi-floor building, you're increasing the chances of interference between the floors. So what we do with dual optimized antennas is we've built two different sets of antennas into each access point that offers this functionality. One that's optimized for your traditional ceiling mount antenna pattern and one that's optimized for wall mounting. So you can choose to switch between wall mount or ceiling mount based on where you've installed the device. There's a physical switch on most of the APs that support this, and all of them have a software switch that you can control, whether you're directly managing the product or managing it in the cloud or with the controller. The other technology we promote a lot of here is smart antenna technology. So I want to talk a little bit about smart antenna technology, what it is, how it works. We go a little bit more in depth into it in some of our other webinars, but I do want to cover the basics. So we sort of have to back up a little bit and talk a little bit about Wi-Fi spectrum, because that once you understand that, you understand how smart antenna is helping you out. So in the US here, when we're talking about 2.4 gigahertz radios, we've got what's essentially 60 megahertz of spectrum that's available to be used by any device. So these channels, as we see them, are actually split up into 22 megahertz in size. So realistically, you've got three channels that you can use before you start in the same area, before you start getting interference between your devices. Now, one of the ways that Wi-Fi over the years has increased the speed and performance of Wi-Fi is increasing the amount of bandwidth being used. So for 2.4, to get the maximum speeds you see advertised on the data sheet or on the box, you have to use a 40 megahertz channel. So the problem you run into, right, you've only got 60 megahertz available for anything that's using 2.4, access points, keyboards, game controllers, microwaves, what have you. So if you go up to a 40 megahertz channel and there's only 60 megahertz available, as soon as you add a second device that's also trying to use 40 megahertz channels to maximize speed, you start encountering interference between those devices. Now, the 5 gigahertz spectrum is much more wide open. That's why there's been a big push to moving more and more devices onto the 5 gigahertz radio, because you can have more devices operating in theory before you start having interference. So if we're looking at 20 megahertz channels, instead of having 3 channels that can be used, you've got like 26 channels that in theory can be used without interference. But again, the way you get the faster speeds that are advertised on your Wi-Fi devices, you have to use bigger and bigger chunks of spectrum. So 11AC Wave 2 Wi-Fi 6 products, to maximize the speed, you have to use 160 megahertz channels. So there's only 2 of those that are not overlapping. So if you're trying to maximize speed, you'll quickly run into issues with interference between devices. The other thing I wanted to draw your attention to here is a huge chunk of these channels are highlighted here in sort of an orangey yellow color. These are what we call DFS channels. So before the FCC decided to open up 5 gigahertz for people to use for networking, it was already being used by radar systems and other legacy types of technology. So what the FCC did is said, hey, you can use these channels for networking, but you have to support what we call dynamic frequency selection, DFS. And what you have to do is before you start broadcasting on any channel, you have to stop and listen and see if it's already being used by one of these legacy devices, such as a weather radar or airport radar or military radar, the most common ones you run into. If you detect that it's being used, you can't use that channel. You have to go find another channel. If you do find a channel, it passes and it's not being used, then you can broadcast on it. But as soon as you detect a legacy device using that frequency, you have to stop broadcasting and switch channels. So this is causing a couple little problems for us. One is, depending on where you're located, you may end up in situations where you are getting periodically disconnected from your radio, which results in users complaining that they lost their network connection. It really sucks if you're doing a Zoom call like right now and your Wi-Fi drops out. The other thing is if you don't have a dedicated radio monitoring the other channels, you can't just switch instantly to another DFS channel. You have to choose that channel and then listen for a period of time before you can allow broadcasting on it. So the downtime can last a little bit of time. And on top of all of this, to get certified to use DFS channels, it can add up to 6 months to the time it takes to get your product FCC certified. So because of this, a lot of consumer equipment doesn't support these DFS channels. So this is a problem we run into in tech support all the time, with people calling in saying, hey, 8 of my employees are on the network just fine, but 2 of my employees can't get on the network. What's wrong with your guys' access points? And usually what happens is we track it down. They're using a DFS channel, and the laptop or their phone or whatever it happens to be that they bought doesn't support those DFS channels. So for that reason, a lot of people end up just avoiding the DFS channels altogether. So as you can see, now you're just limited to these little green blocks of spectrum. So again, you've reduced the number of devices you can have operating before you start encountering interference. So that interference that we talk about is what we call co-channel interference. So in general, when it comes to using radio waves to communicate, each device has to take turns broadcasting. If 2 or more devices broadcast at the same time using the same frequency, it causes interference, it causes those packets to be dropped, and they end up having to be rebroadcast. So you run into this primarily in areas where you've got a lot of access points within range of each other because you're overlapping those channels trying to maximize your speed, or you run into these issues in situations where you've got a lot of devices connected back to your access point, and the devices themselves may be talking over each other trying to reach the access point. And we go into it a little bit more in the Wi-Fi 101 webinar, where we talk a little bit more about why that happens and how it happens. But the solution to that is smart antenna technology. So in this example here, we've got one access point broadcasting. As soon as we add a second access point that's using overlapping frequencies, we start encountering this co-channel interference. And it doesn't have to be another access point. It can be anything that's putting RF using that spectrum. It can be industrial equipment. It can be other wireless devices, etc. So the way historically we've tried to solve this problem is you would do, very careful sitemap planning of how you're going to deploy your APs, where they're going to go, what channels each of them are going to use. And then you would reduce the power so you wouldn't get as much overlap between your wireless devices. It works, but it requires a lot of hands-on calculation generally, a lot of planning that goes into it. What you plan on paper doesn't necessarily work in the real world. And more importantly, as you reduce the power of the access points, you're worsening the signal to noise ratio. So you're lessening the speed of your connected devices. So you're trading off performance issues due to co-channel interference to performance issues due to signal to noise ratio issues. So smart antenna, or in particularly our smart antenna design and algorithm was designed and optimized specifically for co-channel interference. So it's designed to increase capacity. You can put more devices on the same access point before you start encountering issues. You can also put more APs in the same area before they start interfering with each other. The smart antenna is able to focus the beam so you can increase your coverage area. So this is your traditional, ceiling mount antenna. It's got a fixed antenna pattern that's roughly circular that radiates out. If you're doing outdoor point to point, you've got a fixed antenna that focuses the beam in one direction. Smart antenna sort of combines these two together. So basically what happens with smart antenna technology In this case here, we're showing here's your AP, here's a source of RF interference. With smart antenna, we have the ability in this scenario to go through hundreds of different antenna patterns and optimize the antenna pattern for each connected device. And our algorithm, when deciding which antenna pattern to use to cover what's going on, doesn't just optimize based on where the client device is in relationship to the access point. It also takes into account other sources of RF noise and tailors the antenna pattern to not listen and not pick up that interference at the access point level. So like I said, this allows us to put a lot more devices on the same AP or put a lot more devices, including access points in the same area. So it's really, really beneficial in, conference rooms, meeting centers, expo floors, hotels, smart classrooms, things like that. So we've got another example that we go through on one of my other, Wi-Fi, or excuse me, our Wi-Fi 101 presentation. We go a little more in depth, but here's a quick comparison between us and Aruba. We've got basically here the same configuration on the 5 gigahertz radio. This is showing 2.4 performance. Smart antenna outperforms it. You go, well, that's because your 2.4 is a faster radio. So here's comparison on the 5 gigahertz radio, same basic antenna, the same Wi-Fi 6 technology. The only difference is smart antenna versus standard antenna. And you can see much better performance. And that's before taking into account things like co-channel interference. So a while back, a third party got together. It was a few years ago. It was the University of Brescia. Their information technology group has a networking group inside of it. And they decided to test claims made by us and Ruckus about smart antenna technology. So they bought our smart antenna AP, they bought a Ruckus smart antenna AP, they bought a Cisco AP, they bought an Aruba AP, which don't have the smart antenna technology. And they put them through their paces and basically confirmed that what we said, we shine when it comes to real world environments where there is going to be co-channel interference with up to a 70% performance enhancement, even 45% better than Ruckus's technology at that time. So you can go through and Google this, University of Brescia. They have published the full testing regimen they did, the full amount of the results, all of their methodology. So you can drill down more into it. We've also got on our website a nice little white paper summary of the key findings as they relate to our products. And then lastly, when it comes to technology, I want to talk a little bit here about Wi-Fi 6. So Wi-Fi 6 is a new wireless technology that came along fairly recently. That's basically designed to be a whole heck of a lot faster. But on top of that, they've basically gone through and changed the way Wi-Fi works and made the first really significant changes to the core behavior of how Wi-Fi works that helps solve a lot of the issues that have plagued Wi-Fi since the early days and are still causing issues today. Now, one of the key things here with this Wi-Fi 6 technology is this improves the performance not only on your 5 gigahertz radio, but also on your 2.4 gigahertz radio. So this is the first improvement to the 2.4 gigahertz technology since all the way back in 11N. Any sort of 11AC device you have, the 11AC functionality is only on that 5 gigahertz radio. Your 2.4 is still 11N. So now with Wi-Fi 6, if you're following the spec, both radios are now using the new Wi-Fi 6 technology. So it's a huge leap for the 2.4 radio. So some of the technologies that they've added here is they've increased how many spatial streams. You can now have up to 8 spatial streams, and you can now do multi-user MIMO, both upstream and downstream. So with 11AC Wave 2, you could do multi-user MIMO where the AP could transmit to multiple devices at the same time. With Wi-Fi 6, now multiple devices can transmit back to the AP without causing interference. We've now implemented OFDMA, both upstream and downstream, letting us more effectively utilize the RF spectrum that's available and optimize spectrum utilization based on the demands of the connected device. We've got the ability to do unit scheduling, so no longer are we relying just on a random number generator to decide when it's okay to start broadcasting. The AP can now let client devices know when it's their turn, reducing interference between those devices. We've increased the encoding so you can fit more data in the same amount of bandwidth. We've added something called BSS coloring. So BSS coloring basically adds a little extra information to a packet so that any device listening can quickly determine if that information is intended for them or intended for another device. So it allows APs to sort of solve some of the interference issues that you get with co-channel interference. It doesn't fully solve the issue, but it solves part of it. So it helps with increasing the number of devices or the number of APs in the same area. And something called target wake up time. This is for your smart home devices, devices that are spending most of their time sleeping. You can specify times for how long they should sleep before waking up and checking things again. So it's an energy saving thing there for battery operated devices and stuff like that. So just a quick thing here. This is just showing here, traditional Wi-Fi has been OFDM. Basically, you could split up, your 40 or 60, or excuse me, 40 or 80 or 160 megahertz channels into 20 megahertz chunks to do multi-user MIMO. With OFDMA now, we can basically split up these chunks into all sorts of different sizes based on what the device needs. So no longer, are you wasting a bunch of airtime. You can more effectively utilize your airtime. And this is just showing here with BSS coloring, you can more effectively, utilize your space here by reducing the amount of interference between APs because of this extra information that's tagged on the packet, allowing APs and other devices to know that they can ignore a certain broadcast. And then just in general, you're getting a huge performance increase um, when you add more and more devices onto the AP. So a lot of those technologies we talked about in the previous slides allow better utilization of airtime, reduce the amount of interference, and better coordinate how different devices are talking. So because of that, with 11AC, as you add more and more devices, the aggregated throughput actually drops because they're less efficiently using the available airtime. Where with Wi-Fi 6, the aggregated throughput remains basically flat. So if you look as you add more and more devices, each device gets more available bandwidth, more throughput per device. And that's especially highlighted here as you add multiple APs because of the co-channel interference issue. Wi-Fi 6 helps maintain aggregated throughput that's flat and gives you an even bigger boost as far as per device throughput availability. Now, one thing we do need to talk about here when it comes to Wi-Fi 6 is there are a lot of products out there that are marketing themselves as Wi-Fi 6, which don't actually meet the standard. So what happened is in the rush, primarily it had been on the consumer products to get products out that you could market as Wi-Fi 6. Um, chipset vendors came out with chips that were based on the earlier drafts of Wi-Fi 6 that don't necessarily support all of the features that are part of the official standard and are requirements of Wi-Fi 6. But these products get to call themselves Wi-Fi 6 because there is no organization or group that owns the trademark to Wi-Fi 6 that can enforce it. Now, the Wi-Fi Alliance will certify devices as Wi-Fi 6, and you do have to meet all of the standards to get that Wi-Fi 6 logo from the Wi-Fi Alliance. But as long as you're not using their logo, you can call pretty much anything Wi-Fi 6. So there's no real enforcement. So a lot of these products are calling themselves Wi-Fi 6, but are missing some of the key features that make Wi-Fi 6 such a big improvement over 11AC. Most of these devices are just basically 11AC plus. They're not truly Wi-Fi 6. So in this example I've got up on the screen, I'm showing the differences between Qualcomm Gen 1 chips and Qualcomm Gen 2. It's the same thing with Broadcom roughly, same thing with any of the chip vendors. All of them came out with these early Gen 1 chips that are missing some of the key features. And they won't tell you this. So you've got to look at the data sheet and see, do they mention BSS coloring? Do they mention, upstream MIMO? Do they mention OFDMA? In both directions. So those are things you have to be aware of. A certain vendor just launched some new Wi-Fi 6 products this year that are using these old Gen 1 chips because they're cheaper and are calling the product Wi-Fi 6. Another thing going on, which some vendors are doing, is they're only putting Wi-Fi 6 on that 5 gigahertz radio. They're not putting Wi-Fi 6 on the 2.4 gigahertz radio, again, to save cost. So you're still using 11N on one of your radios when you should be getting Wi-Fi 6 features and performance on both of your radios. So those are things to be aware of. All Zyxel's Wi-Fi 6 access points are full Wi-Fi 6 compliant, have all of the features, are using the current up-to-date chips. So just to get that out there. And then the last thing to talk about here, when we were talking about the ultimate APs, those 5 and 6 series access points, also in addition to the cloud and directly, have the ability to be managed by a controller. I know there are still a lot of you out there that prefer to use a on-premise controller rather than use the cloud. So I want to talk briefly about that. So if you are using an on-premise controller, you get your, intelligent dynamic channel selection where the controller helps monitor what's going on and chooses the right channels to try to minimize interference. With our APs, if you plug them into the network and you have a controller on the network, they will automatically find that controller. You do not have to manually configure each of your APs and point them to the controller. They will find it on their own. We have our Zymesh technology, fast roaming 802.11 KVNR. And you'll notice here, most of these features are also available in Nebula Cloud. Very, very little difference between them, but for those of you that don't trust the cloud, don't like the cloud, just want to pay a one-time license and be done with it, we still do support these controllers. We do have rogue AP detection and isolation, but I will warn you, in the US, the FCC does not like isolation. So it may be something that gets you in trouble if you do use it. The ability to do edge security, again, something else that now we've added some edge security into Nebula, dynamic VLAN, load balancing, just a lot of the stuff you expect to find here. So that's all available with the controller. So we do have our NXC 2500 and 5500 controller, but those are going away. Most of our USG series has a controller functionality built into it. So you can see here the VPN series, the USG Flex, the ATPs have the controller functionality in there. This first column is showing you how many APs can be managed out of the box. And then this second column here is showing you how many APs can be managed. It can be upgraded to be able to be managed. So these upgrades are done with a one-time license to unlock these additional APs for management functionality. Yeah, and this is just showing you here whether the devices support high availability or not. And then lastly here, I just want to bring this up because this was just published like last month. Network Advisor on YouTube did a really nice in-depth comparison on performance between our Wi-Fi 6 AP and the equivalent Ubiquiti Wi-Fi 6 AP. So check it out. It's again, Network Advisor is the channel, and you can see the title there, Wi-Fi 6 Zyxel versus Ubiquiti. Really thorough testing of the two different devices and how they perform. So you can see the difference, even though the products cost basically the same. In fact, I think ours right now is a little bit cheaper. So now let's start going through the models. So what are the models in our Wi-Fi lineup? We'll start here, 11 AC products in our 1 series. So these are the products that you can manage in the cloud or directly. So we have the NWA 1123 ACV3. This recently launched a few months ago. The 1123 ACA HD, that one is being phased out. So that one's going to go away here in a few months. And then we've got the 1123 AC Pro. On the Wi-Fi 6 side of things, we've got 2 models to choose from, the NWA 110AX, the NWA 210AX. Basically, the differences between the two is the 210 is a little bit faster. It's got double the speed on the 5 gigahertz radio. And because it's got double the speed, we've also increased the connecting port. So it's a 2.5 gig Ethernet connection versus a 1 gig Ethernet connection to be able to support those faster Wi-Fi speeds. Going up here to the 5 series, we've got a couple different models here. We have the new WAC 500. These will be showing up here probably in the next month. So this is a new access point that's replacing the 5123 AC. We have our WAC 6303D-S. So this has got smart antenna technology on it. And then the 5123 AC HD. For wall plate APs, we have two models to choose from. We have a WAC 500H and a WAC 5302D-SV2. Um, by going up to the 5302D-SV2, you get a smart antenna technology and an extra port on the Ethernet pass-through ports on the bottom. We also still have a bunch of the V1s available. So if you aren't using Nebula, we've got a bunch of the V1s still available for those of you that need that. The V2 adds basically Nebula over the V1 of this product. Then going up here to the Wi-Fi 6 side of things, we have the WAC 510D, the WAC 610D, and the WAC 650S. So again, the main differences between the 510 and the 610 is we've doubled the speed of the 5 gigahertz radio. So in addition to the faster speed, we've added that 2.5 gig port. How these differ from the 110 and 210, these also include 1 year of Nebula. So these are Nebula Flex Pro. These can be managed with a controller. These can be used with the new secure Wi-Fi feature that we just rolled out on the USG Flex models. And then the 650S is sort of our flagship here, faster than both of these guys. It's got a dedicated radio for monitoring the RF frequencies. It's got Bluetooth built in, and it's got a 5 gigabit Ethernet connection to help support these faster speeds. And then on the outdoor side of things, we've got two models here. We've got the WAC 6553D-E. So 3x311 AC. You do need to provide antennas. So we sell omnidirectional antennas for these, or if you want to use directional antennas, we use a standard N-type connector. So you can use any sort of antenna that uses N-type connectors. We've got the WAC 6552D-S. So this is a 2x2 with smart antenna, but it's not omnidirectional coverage. It is 90-degree coverage. So if you want to cover a 360 area, these are designed so you can mount multiples on the same pole to get 360-degree coverage. And then we've got this little accessory device here. So this is an outdoor enclosure. It helps increase the cold temperature range that our indoor APs can support. And it also keeps water off the APs, so you can mount the APs outdoors. It works on most of our access points now. There is a revision that we should be getting in stock here in the next couple of weeks that supports the new NWA 110, 210, 610, 510. So it will support most APs, but you do want to double check which APs are supported before you combine the two. But if you'd like to take an indoor AP and make it an outdoor AP, this is the guy you want. So we do have a bunch of products that are in the process or have been recently phased out. So I want to just briefly go through and touch on those. So the NWA 1123 ACV2 got replaced with the NWA 1123 ACV3. The primary difference between these two is we've upgraded the radio from standard 11AC to 11AC Wave 2. The NWA 1302 has been phased out and it has been replaced with the new WAC 500H. So this is a true Wave 2 access point versus the Wave 1 over here. It does support MU-MIMO. It does not have the smart antenna technology, but it is Nebula Flex Pro. So it can be managed with a controller. It does include 1 year of ProPack, neither of which were options on the old 1302 AC. And the NWA 1123 AC HD will be phased out here in a few months. So depending on how you think of things, the replacement is either the NWA 110AX, our new Wi-Fi 6 2x2, which is very similar in price, or you can go up here. If you don't need the Wi-Fi 6, you could go to the NWA 1123 ACV3. Both are going to be Wave 2 11AC products. A little bit slower speed though on the 5 gigahertz radio versus on the 1123 AC HD. All of the dedicated NAP models are going away. So those were our APs that only worked with Nebula. So those are all in the process of being phased out. So the NAP 102, the replacement would be the WAC 500. NAP 203, nearest replacement would be the WAC 6103D-I. NAP 303, the replacement would be the WAC 650S. And then the NAP 353 will be replaced with the WAC 6553D-E. And no, I don't expect you guys to remember all of this. NWA 5123 AC is being phased out, again, replaced with the WAC 500. The WAC 5302 D-S is being replaced with the D-S V2. So the main difference between the two is we have added support for Nebula to the WAC 5302. The V1s, and again, we still have plenty of the V1s, do not support Nebula. And then the WAC 6502 D-S and the WAC 6503 D-S are both being phased out. If you need smart antenna and 11AC, the WAC 6303 would be the nearest replacement for both. Otherwise, we're promoting the idea of it's time to move to Wi-Fi 6. So if you're looking for Wi-Fi 6, the 6502 would go to the 610D, the 6503 would go to the 650S. And this is just showing you here Wi-Fi 6 versions of all of these. This is the nearest Wi-Fi 6 model for each of these that you would move to. So something we don't do very often, at least in my webinars, is talk about the competition. So I figured this presentation today, we'll do a couple slides on us versus the competition, just so you know which models we are competing directly against with our competitors. So we'll start off here with the Zyxel NWA 1123 AC Pro. Our biggest competitor in this space is Ubiquiti with their UAP AC Pro. Our pricing should be very competitive with the Ubiquiti product. We include a lifetime warranty with the NWA 1123 AC Pro versus a 1-year warranty with Ubiquiti. So just on that alone should be enough to justify the switch from Ubiquiti to us. We have higher output power on both of our radios compared to the Ubiquiti. We support more SSIDs per radio than Ubiquiti does. We offer dual optimized antenna, where Ubiquiti just has the single optimized for ceiling antenna. Full SNMP V2C and V3 versus SNMP V1 on the Ubiquiti. Dual image firmware, preventing the device from being bricked if something happens during a firmware update that corrupts the firmware file. And a dedicated console port. This would also be what we use to compete with a Cisco WAP 371 or a D-Link 2695. Next up here would be the WAC 510D. So this is our Wi-Fi 6 2x2 access point. Again, ours has a dual optimized antenna. Our competitors just have that single ceiling mount antenna pattern. In the case of the Ingenious models here, the Ingenious models don't support the full Wi-Fi 6 feature set. They are missing the upstream OFDMA, they are missing upstream MIMO, they are missing BSS coloring. We support all of those, as does Aruba. Again, we've got better output power than our competitors here, quite significantly on the 5 gigahertz radio. We do have, let's see here. So those are going to be the main differences here. We do offer the cloud management, the free version of Nebula, which either Ingenious or Aruba offer a free cloud solution there. So this is just showing here comparing our WAC 650S against some of the models here. So Cisco's 9115, the Meraki MR45, the Aruba 535, and the Ruckus R750. Excuse me. Again, smart antenna, only us and Ruckus offer smart antenna in this segment. We've got stronger output power than Ruckus and all of our competition does on the 2.4 radio, and more than most of our competition on the 5 gigahertz radio. We offer a 5 gig uplink port, where all of our competition maxes out at a 2.5 gig uplink port. So you end up in a situation where your Ethernet connection may be your bottleneck to full Wi-Fi performance with these new Wi-Fi 6 radios. So that's it for today's presentation. If you guys have questions, send them in under questions and answers. While I'm waiting for any questions to come in, just want to highlight for you, we do offer our forum, forum.zyxel.com. This is a user forum for users to be able to help talk to each other. It is also monitored by our R&D and our headquarters PM team. You will occasionally see them waiting in to answer questions, although they definitely are reading everything there and taking that feedback. It's also where all of our new product announcements go. It's where security announcements go. So if there's a security bug that gets released and we have a patch to fix it, you will find it on forum.zyxel.com before you find it anywhere else. So it's a really good idea to go there, choose the business forum and bookmark that and check that periodically to see what's going on. And then my email is up there on the screen, seanr@zyxel.com. Feel free to give me feedback. I'd love suggestions on other webinars that you would find beneficial for yourself or those members of your team. We're always looking for new ideas for webinars because some of these things get a little bit stale doing the same thing. So we need those suggestions of what you would consider beneficial. So we do have a question here from Tony. Tony is asking for a customer facing version of this presentation. Tony, reach out to your salesperson. Um, that would be either Jacob, David, or we've got a new sales guy in the West Coast, Andy. Reach out to them and ask them for that, and we can put together something for you. I don't have one available right at this moment, but we could certainly trim this up a little bit and give you something that you could use to show your customers. Absolutely. So with that, guys, that was the only question that came in. So I'm going to go ahead and end today's webinar. Again, feel free to reach out to me with questions, feedback, suggestions, how we can make this time that we spend together here a little bit more valuable for you. And thanks for joining us. I really appreciate you taking the time out of your day to sit through this. Thank you.